Off we go. So yeah, today we're going to learn how to make functions in Python. Beautiful. I'm very excited. I hope you are too. Before that, though, I do want to get to a different kind of loop, just because it's going to be useful for you one day. So give me 2 slides to talk about a different kind of loop, and then we will get to making our own functions. Okay? So we learned a loop in Python called a while loop. We say while something. It's going to continue to run as long as the condition that we put in the while loop was true. There's another kind of loop called a for loop. It has the word for instead of while, and it does something cool and nice, but honestly, it gives us no new power. It just makes our lives easier. So technically, you don't have to pay attention. You never have to use a for loop if you don't want to, but I will prove to you that it does make our lives much easier for the cases where the for loop helps us. All right. It is, though, we gain nothing with it. It is equivalent in power. Equivalent in power to a while loop. So you don't have to use a for loop, but I promise it will be helpful. And what a for loop does, you do say for instead of while, it goes through, it iterates through, that's the fancy Latin root word, right? It iterates through something that is iterable, and at least for this class, I want you to think of the word iterable as like a list. All right, so a list is something that we know and love, and it's something that we can go through, right? A list L, like I can give it some stuff like 4, 5, 6, and it's got all those indices, right? It's like 0, 1, and 2. So if we wanted to like move through the list and like print out every element or sum up all the values in the list, what we did before is we made a while loop that range that iterated through the indices, right? Start index at 0, go into the length minus 1. That was a little complicated. A for loop is just going to do it for us. It's going to go through every element from left to right, give it to us so that we can use it. All right. So yeah, pretend that iterable things are a list. There's another function that I want to teach you that's going to work the same, but like it's all kind of going to make a list at the end of the day. And here's what a for loop looks like. All right. It looks like this. You say for, and then you give a variable name that you haven't used yet. Let's call it x. And then you say the word in, and then you give your iterable thing, the thing that you would like to go through. So let's say we want to go through L. So we'll say for x in L, and you give a little colon, and then you have your body. Body goes here. As many lines as you want indented that work on the value that you're looking at right now, and it gets called x. All right, so hopefully you can kind of see what's going to happen here. X gets a chance at being every element of L. Just for the first, it's going to run the body with X being set to 4 the first time, 5 the second time, and 6 the last time. Does that kind of make sense? That's what it's going to do. It's going to go through that list and set each value to this variable that you want to call X, which is great. And then you can use X for whatever you want. And so you don't have to like use a while loop to go through these indices. You don't even have to touch the indices. It's just going to go from left to right through your list. All right. So let me show that to you. And I'll just like print out every element of the list with the name that we're giving it here. So I better open up idle. And so that x is a brand new variable name, one that we have not used yet. For every x, for everything in L, call it x. X gets a chance of being everybody in L. Right there. So this is lecture number what? Lecture 23, apparently. So I'll save a new file in a new folder. Lecture 23. So that you can have this later. And what should I call this file? I'll call it forloops.py. Alright, I got too many things open. So let's make a list. Let's be like, alright, list L, let's do exactly this, 4, 5, 6. And then I will iterate through this list with a for loop. I'll say for every x value in L, for everything in L, call it x. And then I get to do stuff in the body. So what's going to go on again is that x is a new variable name. It gets a chance. X gets a chance to be every element of L in order. That's what's going to happen, okay? Every element in order from left to right, that's the way it works. And so what I want to do with X, let's say that I want to print out every element of the list, and so they all get a chance of being X, so I'll just say print X each time. And so kind of, can you imagine what's about to be printed on the screen when I run this program? Look at it. It goes through, and it prints 4, 5, and 6 as X gets a chance every round at being every element of the list. Once the list is finished, the loop stops, because it's like, I've gone through the list now. I'm done. Does that make enough sense? Are there any questions about that? Do you see how that's going to be a lot easier than like, all right, let's start an index variable at 0. Let's remember to increment it inside of a while loop each time. This is simple. Much, much simpler. So our lives are easier slightly because of that. There are other things that are iterable that are not lists. There's a function that kind of makes a list for us. Because we also were using a while variable to just like count up from 1 to 100 or something. That's very kind of tedious again, because you like got to start a variable at 1 while it's listed to 100. There's a nice little helper function that generates a range of values for us, and it's called range. All right. So you can give it two things, starting value and ending value, or you can give it just the ending value, and just a function that's built in. There's no library necessary. What happens when you say range is it gives you a kind of a list between your starting value and then 1 minus the ending, or the ending value minus 1. So if let's say that we wanted to generate the numbers 1 to 10 very quickly with this range function, we would call the function range with starting at 1, and then the ending value, we won't make it 10, we'll say 11, because it's going to go up to this one minus 1. So it will generate from 1 to 10. So it's kind of like the range function generates with the first number inclusive and the second number exclusive. If you've seen that kind of notation in a math class before, that's the kind of things that it generates. And you only have to give the ending value if you want it to start at 0. So if you just want the numbers from 0 to 100 just very quickly, you don't have to make a loop to do it. Like the range function will do the loop for you. You just say range up to the ending value, but not like one more though, right? Because it goes up, but not including it. So you'll say range 101 to generate the numbers from 0 to 100. So by default, the starting value is 0. So if you want it to be something different, you better say both things. So that's what range does, and it pretty much generates a list. Let me prove that to you in the REPL. Like if I want to make the numbers 1 to 10, I'll say range 1 to 11, but it just prints back out as range 1 to 11. It's trying to be efficient. We can convert that to a list though. And we didn't need to do that if we wanted to go through analytics. But range 1 to 11 makes the numbers 1 to 10. Okay. And then convert to a list, range 101. We'll make all the numbers, big long list from 0 to 100. So we don't have to make a loop to do that. So we'll go through the numbers now. We'll just do like 4x in range 111. See how nice that will be? So that's what we want. And I think that's what I wanted to say. So yeah, let's do that in actual code now. Be like, all right, I'd like to, let's say I want to print out the numbers from 1 to 10. So another way to do it then is to generate the range from 1 to 10 and just go through all of those for every y in range 111, right? Because that generates from 1 to 10 inclusive. It's 11 exclusive. And I want to print that y, whatever y is. So it'll go through the range in order from left to right, and that's going to get us, let me print a blank line in between so we see that what's new. There's the old stuff. And then here I am printing from 1 to 10. You see how simple that is now once you get the hang of the range function? Are there any questions about that? So it generates a range of numbers for you, so that you don't have to do it yourself in a loop, because that's a little complicated maybe. So I think that's more or less what I wanted to say about ranges. Let's, I don't know, for one last good example, let's sum up all of the numbers from 1 to 100. All right. So I'll show you, because we kind of did that with a while loop before. Let's do it with a for loop now. I would like to sum up all the numbers from 1 to 100 using a for loop and using ranges. So what does that mean? I'm going to do a blank line here. I kind of I need to go through, right? 1, 2, 3, 4, 5, all the way to 100. So I must iterate, right? Iterate through all the numbers between 1 and 100. That's my goal right now. And then what I want to do with each of them, I want to like take them and add them into like a sum variable, right? And add them into a sum variable. Let's call it sum each time. Right? So sum better start at 0. And then I like to go through every number between 1 and 100. We could do it with a while loop, but we can also do it with a for loop. For every number z in the range from 1 to 101, right? Because it's exclusive. This will generate 1 through 100, yes? And then what I want to do with z, each z is a new value from 1 to 100. I want to take all of them and add them into the sum variable. See how clean that is? You don't have to worry about incrementing z. It's like it's part of the range now. It's fine. Right? And then by the time it's done, the sum will hold the correct sum of all the numbers from 1 to 100. Do we see how that's going to work? Z gets to take on every value in this range. It's generating the numbers from 1 to 100. Z gets a chance of being all of them. And then each time we have a new z value, it's a number that I want to add into my sum. And the loop will just stop when the range is completed. It's beautiful. And apparently the answer is 5,050. 50-50. Beautiful. Yeah, I think that's what I wanted to say. Are there any questions about for loops, range function? Just trying to make our lives easier. You don't have to use them. You could do the same thing with a while loop, and we did the same thing with a while loop before. But once you get the hang of these things, I think it makes it a little bit easier. Yeah. All right. If we are happy, I'm ready to go to the main course of the day. Let's talk about functions. Let's learn how to make our own functions. Because we have been calling other people's functions, library functions, built-in things like range and list and all that. Let's make our own. We did this in Scratch, technically, right? That's when we made our own blocks in Scratch. So that's a thing. You can make a block in Scratch that like takes something, like an argument, if you think about it like that. And then you can plug things in. And kind of what happened in Scratch, if you were to do this in Scratch, I didn't really teach the part that took a thing, but we did make our own blocks at least. So in Scratch, kind of a function is a custom block, and you can ask for something here. You can take a parameter, is what it's called in the definition, and every time you use your block, you have to supply a value there, and that's like giving an argument. All right, so that's an argument. And essentially, every time you ran your custom block with this value, because you could have run it with some other thing, could have run it with 42, 43, whatever. What happens when you run that block is it jumps up to the definition and starts running all the code in the definition with, when you have something special here, with this argument set into this special variable, because it needs to run with whatever you gave it, and it's going to be called whatever you name it up here. And this value is called a parameter. All right. When you're defining a function, it's not called an argument anymore. It's called a parameter. All right. So it's an argument when you use it, but in the definition itself, it's got a special name and it's called a parameter. So you can say the word n now inside the definition. You're giving whatever you just received when the block was used. So like if it was 42, n is now 42. N is now 42 when you run this one, or if it was 43, n will be set to 43 for the duration of this call to your custom block function thing. Okay, so that's kind of what's going on, and yeah, we know how to call functions in Python, right? We say like the name, give it some arguments, get the return value potentially. Like we were just calling range, right? Range 101. 101 is like an argument to the range function. But we can make our own range function now, all right? If we want to define a function, we kind of need the opposite. We do need the name still, and then for as many arguments as we wanted to take, we need a name for each of those things. We need a parameter name. So name of the function, names of the parameters, and how many parameters we need. And then you also have to give the body of your function. Like, what do you want to have done when you are supplied with all your things and somebody asks you to do your computation? Okay? So let me show you how to make a Python function. Now you can make as many as you want. I think, yeah, well, let's do it. So the way to make a Python function, to create one, is you say def. That starts it. Def for define a function. All right? So you say def. And then you say the name of your fancy function that you're about to make. You say its name. I'll just call it func name. Call it f. Call it range. Call it whatever you want. And then you give between parentheses all of the things that you want to take. So like if your function takes 3 things, you need 3 names here, 1 for each thing you're getting. So those are your parameter names, all right? That's what those are called. And so it's kind of like it's being called almost. Give the names of your parameters, P1, P2, as many as you need, all right? Those are your parameter names. Those are the things you're going to be called with. And that's you giving them names as you get them. And then you give a colon. Just like everything else that has like a body, you have a colon, and then you tab over, or idle does it for you. And then you give the body of your function. How do you want to use the things that you got to do the thing you meant to do for your particular function? All right, so your body goes here as usual. All right, that's the secret. And now you can use your function as much as you want. Once you give it meaning like that, now you can call it, right? Every time you call your function, you say its name, right? Func name. And you give all the things that it needed, as many arguments as you had parameters. So let's say that we only had 2. So let's say that it takes 2 things. We'll give it like, all right, I'm going to call it with 42 as the first thing and 43 as the second thing. And those are my arguments. And then every time we call it, what will happen is this. I'll use rainbow for effect. Every time we call it, we jump up and we run the body of our code. We give the meaning to our function. And we jump up here, we run the body with 42 going into P1 and 43 going into P2. And we can use P1 and P2 up here to talk about whatever we were just giving. Because maybe you call it again with 41 and 42 rather than 42 and 43. Like P1 and P2 get to be whatever we're given to you. Right? That's kind of the magic of it. It's just a variable, a special kind of variable. That's what a parameter is. All right? So every time you call your function, the value of your parameters gets set to the arguments that you passed. Right? That's the goal. So yeah, just try to keep those terms straight. They're a little weird. So the parameters are the names of, they're variable names. They have to be variable names. They're what you got when you were called. In the definition, you use them. And then the arguments are the things that you give to your function that will take the place of the parameters. All right? That's the goal. These didn't have to be variable names, did they? You just like hard code things. They could have been variable names, but whatever you give there is going to be passed along into each parameter. All right? Does that make enough sense so far? I think an example will really help. Are we ready for that example? All right. So let us make a simple function that prints all the numbers from 1 to some number that the user gives us, so we can run it differently every time. All right? So here's kind of how I want to call my function. Let's give it a name. Let's call it like print from 1 to something. Print from 1 to like 5. We can pass something different here every time, of course. It's a function. And then its goal is to go off and like print 1, 2, 3, 4, 5 to the screen. All right, so that's the function I'd like to write right now. And this is an argument. I could give whatever I want here. I print from 1 to 15 if I wanted to. That's the beauty of functions. They go off and do different things. And so whatever we give here, we need to hook into. And so that's our one parameter. We need just as much space as what the user's given us. So let's call the thing that we're given n, all right? And so our function's going to look like this. It's going to be like def. Let's make the function, define it. Its name is print from 1 to, and it takes one thing whenever it gets called. And so I'm going to give a name to that one thing, n. That's my parameter, all right? Colon, and then I have a body, and I will print, using that n variable, all the values from 1 to n. I'll use like a loop, okay? Is that making a little bit of sense? I'll go to code in just a second, go to real code in just a second, but that's pretty much what happens. Every time you call your function, it's going to jump down into here, and it's going to set your argument that you passed into the parameter in the definition. So like when this function gets called just like this, we're going to go down into here, and like n is now a variable that exists. It will be set to 5 for this particular call to the function. Does that make sense? Special, so that we can hook into whatever we were given. Because it could have been, like, we were called with 15, then n would have been 15. Okay? So we get to use n for the duration of the function call. It's a variable that only lasts for the function call, though. Right? So n only exists inside the function. It's just for us to talk about what we received. N only exists inside the function call, inside the body. All right, so that's kind of what happens when you get called. It kind of jumps into here, runs all the lines down in here with n, with your variable name, with your parameter name set to the argument that was passed to you. All right, that's the goal. And here is the implementation. I'll make a new file. We'll call it functions.py. And here's what I want to do. I want to say, all right, def print from 1 to, and it takes some variable, it takes some first thing, right? One and only thing, the thing that I want to print up to, n. That's a number, all right? So now whenever we're called, we get to use n. That was what was just passed to us. We get to use n here to print from 1 to n, right? So I'll do the magic in just a second, but let's say we were called, right? If we call ourselves like this, print from 1 to 5 or something, that's a call to our function. It will jump up here to the body and run everything with n being set to 5. All right, that's how that's going to work. So, all right, using n, how do I print all the numbers from 1 to n? Well, I can do how I was doing over here with like a range, like here with a range. That would work. Well, let's do that. Let's be like, all right, I was given n. I know that 1 is always my starting value, so I would like to loop through all the numbers from 1 to n, right? For every x in the range from 1 to n. And remember that this is exclusive, so if I want to go up to n and include n, it needs to be up to n plus 1. That last one is exclusive, so now this will make the range from 1 to n. And x gets a chance of being all those values. Oops. N plus 1. What's going on? There we go. And then I need to do a colon. Oops. Colon. And what do I want to do with each x? I want to print it. Does that kind of make sense? So x gets a chance of being all the values from 1 to n. Print each value. That's what I want to do. Let's watch it work. Oh, look at it go. Beautiful. So I called it with 5. We jumped up here. N was set to 5. And we ran this code with n being 5, which printed 1 to 5. You see it all coming together? Are there any questions about this so far? Making sense? That's quite nice. And the magic of functions, right? The beauty of making a function is so that you don't have to reinvent the wheel every time you want to do something similar. So let's say we want to now print from 1 to 10. I don't have to do anything, right? I don't have to think very hard. I've done it in a general way. I can just recall my function and pass 10. Does that make sense? Because now what's going to happen when I call this, it's going to pass 10. 10 is my argument. 10 will go into n now. It'll run all this with n being set to 10. And that's exactly what I want, right? So not only can it print like that, you can recall your function with new values, and like n is whatever you gave, and it will use that value. And it'll print from 1 to 10 just as easily as it printed from 1 to 5. That is why functions are necessary. So you don't have to think too hard. Just do it the hard way once, and then now your life is easy. Yeah? Any questions about any of that? We want to recall our functions. That's the reason you want to make a function. Don't make one unless you're going to call it at least a couple times. So yeah, there's that. And this was a function that just kind of went off and did something for us. Yeah? Just kind of went off and did something for us. That's different to some other functions that we've used. It's like if I import math, it doesn't make any sense to say math.square root of 2 on a line by itself, does it? I hope you see that. This line, like it goes off and it prints stuff from 1 to 10, but like this line, that does the computation, but do you see how there is no output? I never printed the answer. So this line kind of just like, it did the work, but we lost the answer. You see that? Square root gives a value back. Yeah? It gives a value back, and we better save that somewhere, or like immediately print it. Do you see the difference between this and this? Are there questions about that? Because like that's a little subtle. Like this one can be called by itself because it like goes off and does stuff. And like square root, just it gives a value back. It gives a value back. You need to say what you want done with that value. You will lose that value if you forget to assign it to something or immediately print it. Like you got this option, you could say immediately print the value. It's a different kind of function. All right. So some functions give things back, and there's a way to make those kinds of functions, and you use the word return. That's how you give something back to whoever called you. You say return that thing. Okay? So yeah, like we said, some functions do stuff, like the print function, for example. The print function, you can call it on a line by itself, print hi, and that will legitimately print hi to the screen. Like it goes off and does something for you. Print gives nothing back though, right? It makes no sense to say this. See that? That looks weird. Print does not result in anything. See the difference there? So with enough examples, I will drive it home. So some functions do stuff, while other functions give back answers. All right. So like square root gave back an answer. There's a min function in Python that you can imagine also gives back something. So you say min 2, 3, it'll give you back the minimum of the two things that you gave it. And it's your job to use that in some way. All right? Others give back results like min 2, 3 will result in the number 2, and it's like it got replaced. When you have a function that gives something back, it's like it got replaced with the thing it resulted in. That's how you can think of it. So like min would give back 2, and then you better put it somewhere, because it's as if, like if you called it, right, min 2, 3, it's as if you said on a line by itself 2. Does that kind of make sense? That's why you want to put it somewhere, right? Put it into an x variable, because it's going to result in whatever it becomes. Okay? So I hope with enough drawings that idea kind of makes sense. So it gives back a value. You better use that value. All right? You can use it in a larger context. You can do something like this. You'd be like, all right, min 2, 3, let's add the result to max. There's also a max function, max 2, 3. So this will become 2, right? And this will become 3, and it will create the number 5, because they give back values, okay? So you can do stuff like this, like print min 2, 3 plus 1, because this, for all intents and purposes, will be replaced with its answer. And we've been using function calls like that before, okay? So that's how that works. So we better use it, right? Use the value, immediately print it, assign it into a variable. Don't just call it on line by itself, because it's as if you said just like 2 on a line by itself. That makes no sense, okay? Likewise, print must be called on a line by itself. It makes no sense to ask for the value that print gives me back. I'm just needing print to go off and do something for me, right? It gives me nothing back. It's not going to result in 42 or something. There's no need to hold on to what it gives back. It doesn't even give back anything at all, right? Which also means that you can't use print in a larger context. You can't like add the result of this print call to the result of this print call, right? Because there is no result, yes? It just goes off and does something. That's different than min and max and square root. Those values give things back, okay? So if you want to make a function that gives something back that can be used in a larger context, that kind of gets replaced with what it gives back, you say return. You say return, and then you say what you want to give back from your function call, all right? So with all of those words, I'm ready to make an example, okay? So do yell at me if you have any questions. I'd like to make a function called sum. It's going to be very simple. It's going to take two things. It's going to add them up. It's going to be a plus. It's going to be a wrapper around the plus operation. So that's my goal. I'm going to make a function called sum that takes two things and gives back their sums. Like you call it like this, sum 2, 3. It will result in and give back the number 5. Right? That's what I want to do right now. And that will show us some cool things that we can do here. So the whole point of giving values back again is that I can use my function in a larger context. It's like it gets replaced with its answer. So sum 2, 3, like I can take that and immediately multiply it by 10 or something. That's fine. Or I can multiply it by 2, whatever you want. And then it creates 10, doesn't it? Like it uses the value and another number and the operator, okay? So let's make a sum function, and we're going to say return our answer, okay? That's what we will do. Print system empty space. And so I'm going to make a function that needs to be used not just on a line by itself. So I'm going to make a function called sum, def sum, and it's going to take two things. The two things that we were given, I'm just going to add them together. It's going to be simple. It's going to be addition. It's the addition function, all right? So it's kind of contrived, but it's a good example. So you're going to say return something, return blah. That's kind of the line that's going to look like when you want to give back a value. When you want to give back blah specifically to whoever called you. So if I want to give back, what do I want to give back from this function? The sum of x and y. I will compute then x and y, x plus y, and I will say return that. That's how you do it. Say return space, whatever you want to give back to who called you. So that now sum is a function that gives a value back. I didn't say return up here, so this function gives nothing back. It just does the thing. That's the difference. See it? So yeah, now we can call sum and use it in a larger context. We can be like, all right, we can do this thing. Be like, all right, let's call sum 2, 3. I can multiply the answer by 2. That'll create 10, right? And then I can immediately print whatever was given to me. You see the difference between the way I was using this function and the way I'm forced to use this function. It's giving back a value. It's returning it to whoever called me. All right, so that's another way to print 10 apparently. Does that make enough sense? Like this call, because it gives back a value, because it returns the answer, it's as if this gets replaced with 5. That's what function calls that give things back kind of look like. And then it computes 5 times 2 and prints that. Yeah, that's how that works. It makes no sense to say this, sum 5, 10. Does that kind of make sense? Like if I call this now, I see no 15 anywhere, right? Because printing is how we show things to the user, yes? It's as if we set it on a line by itself, 15, and moved on. See that? Because it's going to get replaced with 15. That's what it gave back. There's a difference between giving back something so that you can use it in a bigger place and then printing something. Okay? It might be a little convoluted in our head right now because the way that we've been doing stuff is just printing in code, but there is a difference when we're making functions. Okay? So this is useless. We're not doing anything with the result. Sad face. Right? So we better do something with the result if we want to use it. What could we have done to fix this? Well, we could have done sum 5, 10 and then just immediately printed it, or put it into a variable, or immediately printed it, because this will result in now 15, and it's as if you said print 15, and that makes sense. So there it is, beautiful. Okay, I think that's what I wanted to say there. Are there any questions about that? Before I continue with the example, I'll make sure that's being as clear as possible in our heads. So let's see here. Do I want to do that differently? I think I want to continue along these lines. Okay, so yeah, what did I just say? When you return a value, you can use the result. If you don't return a value, you cannot use the result. All right, you're forced to then only call it on a line by itself because there is no answer. All right, so let me make a bad version of the sum function, and I'll show you kind of the difference. So here's the good sum function. I'm going to copy and paste it. I'm going to make a bad sum function. All right, I'm going to say sum bad. I'll give ourselves some space in the output there. And so, all right. Because when we're first learning about functions, returning and printing, they kind of seem like the same thing. So instead of giving back, instead of returning x plus y here in sum bad, I will say print x plus y. And this won't do what I want all the time. All right, so notice the difference, return versus print. And let's kind of talk about why this is bad. So this function now is incorrect. I cannot use it in a bigger place. It's just printing stuff. It's not giving back any answers. It's not giving back the answer. Okay? So that's unfortunate. Because now maybe we wanted to do this. Print sum bad 2, 3. This is going to look really weird in the output now. Alright? So I'm calling the bad function. Watch what happens. It does print 5, because that's part of the thing. It prints 5. And then it also prints a weird thing. It says none. Huh. Let's figure that out. All right. So why did it do that? Well, let's kind of walk through what's going to happen when we call this. Well, it needs an answer. Print needs to know what to print. So it's going to go off and call this function first. Yeah. So it's going to jump into here. X is 2, Y is 3. And it does print 2 plus 3. So it will print 5. And then this function is done. And print needed an answer from that function. It did not get back an answer. You see that? So the special value in Python to indicate that we got nothing back at all is called none. And so it's as if print saw this. All right, the result was none. I'm going to print none. Does that make sense? That's silly, but that's why. All right, so this turned into print none. Okay? And just the same, like, this will be extra weird. This won't even work if I do this. It'll be like, all right, print sum bad 2, 3 times 6. This is an even worse error, because this is kind of how you want to use a sum function, right? You want to like use it in a bigger context, like multiply 5 times 6. That will not at all work here. Oops. I will get an error, in fact. So not only that, it will print, here, we have an empty space. It will print 5, and then it will say error. I don't know how to multiply none by a number. Do you see the problem again? So print saw this, and it's like, I don't know what that is. I need to compute the answer first. So it's like, I know what 6 is, but I'm not sure what this answer is. So I'm going to go off and call sum bad to get an answer so I can multiply it by 6. That's what it's going to do. So it's going to jump into here. It's like, all right, 2 and 3 for x and y. I will print 5, because that's the line, right? That's what runs in this body here. So sum bad prints 5 there, boop, just like that. And then again, it gives back nothing at all. So this results in none. It's like, all right, print now needs to multiply none by 6. See that? There is no answer to that. So that's why it complains. So this turns into, dun, 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 it's like print none times 6. You see that? That is unfortunate. So that is no fun. Whee! And that's why we get an error. Does that make a little bit of sense? That's what's going on there. So there's a big difference between printing a value and returning a value. For something that you want to use in a bigger place, you got to return. And then you can use it, but then you better remember to like print the answer, save the answer somewhere, because like it's not going to be printed when you return. That's the trade-off. All right. So there is a way to kind of explain this. It's a more advanced topic. I want to draw a picture for you. All right. I want to kind of draw a picture of how these functions are running, and that will also help, because I want to show you that it's not as magical as you think. So let's say we want to run, let's see, this line. Let me kind of show you what's going to happen. Or no, let's do this line. Let's say I want to run this line. Let me show you what happens when we run it. Print sum 5 10, like the good sum though, the good sum function. So you can draw like which functions you're in and who needs the answer and stuff like that using a picture, using a diagram called a stack diagram. So secretly under the hood, when Python's running things for you, it's got what's called a stack of work to be done. So you can think of it like a stack of paper. Like you're always piling on top of like all the things that you currently need to do with new things that you need to do. So when you start your program, you've got nothing to do yet. Like you're just on the desk is empty. And then when you start writing code, like you're in the outermost code, you're not inside of any like bodies or functions or anything. When you're just in the outermost code, like you've got some lines there. That's where we are. So we're in the outermost code, and this drawing will eventually help us understand like who needs what and why things are working the way they are. And then we called print sum 5 10. So like what work needs to be done and in what order. The next thing we need to do eventually, right? The outermost thing. The new outermost thing to do is printing, right? So we're going to save that knowledge on this idea of the stack. That's what Python's keeping track of. All right, I was in the outermost code, and now I see that I need to print something. So I better save the fact that I need to print something, because I'm not ready to print something yet. So it just saves the fact that it needs to call print, because it also needs to call this first, right? Print needs to know what it needs to print. It's like, I don't know what this answer is. I better go figure out that answer. Does that make sense? So print is kind of like waiting. It's one of the stacks of work that needs to be done. And we're going to add on to the stack of work. Well, the first thing that needs to happen is I better call sum 5 10. I need that answer. I need that answer first. And so print calls sum. And so it's always kind of in reverse order. The person on the top of the stack is like the paper you take off, and like you work on that one first. So it's like sum needs to give back its answer to print. And print was part of the outermost code. We'll continue with the outermost code after print is finished. So that's kind of how a drawing that represents how the code is executing right now. Okay, that's how that works. And yeah, I can draw some pretty pictures in here now as well. Like sum has two things. It has x and y, and those are variables just for the sum function. So I can draw those variables right here. It's kind of cute how that works. And so we called it with 5 and 10. So 5 goes into x and 10 goes into y. So that's how we were running sum. 5 and 10 go there. That does not look like a good 5 to me, though. 5, 10. So those are there. And so sum computes its answer. It's like, all right, 15. My answer is 15, and it returns it. We say return x plus y. And the way that it returns is it looks underneath it on the stack of work to be done. This is why this works. Like, all right, I will give back 15 to whoever called me. It's always the person underneath me on this stack. This is called the function call stack. All right, and now sum is done. So I could erase sum. I'll put a line through it so that you see like where we've been. And now print got the answer of 15 back. Print knows how to print integers. So it sees like print 15. It sees 15 now, and it'll go off and do the actual printing of the 15. Like there's the terminal, there's the output. We printed the 15. Now print is done, and now we're back onto the next line of the outermost code outside of any function call. Right? So like sum gave back a value to print. Does that kind of make sense? That's how you can draw it. And like the x and y were just part of the sum function. So we can put it in its own little stack of paper. Okay? That's how that works. So these drawings are useful once you start having a bunch of functions involved. And it can also, the same drawing can talk about like why this function didn't do anything right, anything cool looking. It printed 5 and then none, right? That was this call. So it'll also explain why this printed 5 and none, why this turned into print none. So in the same reason, like, all right, we were back in the outermost code as that got called. Outermost code. And then we needed to call print, right? Print was the next thing that got called. And then print wasn't ready to print anything. It needed this, right? We're not sure what this answer is yet, so it needs to go off and run the function to compute potentially an answer. So print is going to go and call sum bad. So that's like the order of things. It's in reverse order. So this is sum bad now. Sum bad. So we're in the outermost code. We call print, and print needs to call sum bad because it needs that answer before it prints something. That kind of makes sense. That's the hierarchy. So sum bad is getting 2 and 3. Those are going into its x and y parameters. So sum bad for this call has an x that holds 2 and a y that holds 3. And what does it do? So sum bad is going to, it has one line really, and it prints x plus y, so it's got 5. It's going to print 5 to the screen. See that? And then the whole function is now done. We've run all the lines. So it's going to go back to whoever was calling it. It's finished. And so who was calling it? It's the person below it on the stack. It's like, all right, I'm done, and my answer is nothing. The special value that represents nothing is called none in Python, with a capital N apparently. So sum bad it printed 5 to the screen, and it gave back none to whoever called it, which was the print function. Print was waiting so patiently on the value because it needs to know what to print, and it sees none. So it's like, all right, that's what you wanted me to print then. I'll print none to the screen. Now my job is done. And we're back off another piece of paper into the trash now. We've finished that work. Does that kind of make sense, the difference now? Like sum gave back a value to print. Sum bad did not give anything back to print, so it sees none. And that's what print's going to print. Print's going to print what you give to it. Yeah, that's the secret. Okay. Any questions about that? So I think I'd like now to go to an example of a function that's like going to combine a lot of knowledge. So let's make a fancier function now. Let's make a function that sums up all the numbers from 1 to some value. Okay. This is going to be a bit cooler looking, so it kind of looks like this. That's the start of it, at least. Here's how I want to use it. I want to be like sum 1 to like 5 or something, and then that should go off and compute and return, right? 1 plus 2 plus 3 plus 4 plus 5. That's the goal of this function. And the parent, I think this stands at about 9, 15. So this should give back 15 so you can use it in a bigger place. And yeah, this is the way that we'll define that function. Def sum from 1 to 2 and give a name here. We'll call it n. That's the number I want to sum up to. Okay? We'll start a sum variable. We'll do the work to calculate the sum and eventually give that answer back. Does that process kind of make sense to us, what we're about to do? So it needs to return something again, give back to whoever called you. And that means then that once it works, we could use it in a larger context. We'd be like sum 1, 2, 5 or whatever, multiply the answer by 3. Because like we know that this will give back something. This will result in, right, when it returns its answer, 15. And then the whole thing will result in what? 45. And then we can put that in a variable, use it later, or print it out. Something like that. Okay? So yeah, let's do this one, and just for fun, for practice, let's use a while loop to do the calculation of the sums. Like we gotta start a sum variable at 0 and keep on adding values into it. Sum starts at 0. We want to add a bunch of values into it. Let's do it this way with like an I variable. I can start at 1, and then we'll add the 1 into sum. So this is the age-old thing that we've been doing for a while, right? All the ways of summing. So now we got that one. Go in there. Now make I 2. So we can add in 2 into sum. Now it's 3. Make I 3. So it's always add your value of I into sum, increment I. Now it's 6. Oops. Make it 4. Add the 4 in. Now it's 10. Make it 5. Dot, 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 dot. Yeah? That's what's going to happen. So eventually, once we've gone up to 5, sum holds the answer, yeah? So let's do this with a while loop for fun. Let's do this just like this. Let's be like, all right, I starts at 1, while, right, while I is less than or equal to the value I want to stop at, which is n, right? It's not just 5, it's whatever was passed to us. We're putting that into n. Less than or equal to n. What do I want to do with each I value? I want to take it, add it into the sum variable. Sum equals sum plus I. And then I want to make sure we're ready for the next number. I equals I plus 1. Right? If it was 1, make it 2 next time. When we wrap back around, because this is going to loop. I equals I plus 1. Something like that. Yeah? Do you remember what while loops look like? Does that make enough sense? Because that's going to be our implementation. Okay? Let's do that. And I'll call it sumfunctions.py. And let's do exactly this. We'll be like, all right, def sum 1, 2, some value n. So I'll start my sum at 0. I'll do my work, and then eventually the answer is in the sum variable. It's been filled with the right value. I'll return that value. All right. So now the work, how do I use n and fill into the sum variable? I'll start my I at 1. I'll do all this. I starts at 1, while I is a number I care about. I is less than or equal to n. Right? It's going to start at 1, go to 2, go to 3, inclusive, up to n. I want to add the current value of I into sum. Make it bigger by however much I is. And then set I equal to I plus 1. So then I'm ready for the next round. I'm not going to add 1 back in again. I'm going to add 2, then 3, then 4. Advance it. Does that make sense? So by the time this is completed, sum has been filled with all the relevant values that I care about filling it with. And I've got the right sum in the sum variable, which I can return. Does that make sense? So I can use it now and be like, all right, sum 1 to 5. Multiply the answer by 3. Print it. Print that final result. So this is a return 15, as if I said 15 times 3. And print that. Look at that. So there's my 45. It's beautiful. So this right here is us give back the final sum. Just like that. Are there any questions about this code and why it's working? You kind of see it coming together. It's returning something, so you can't use it online by itself, as if you said 45 and moved on. You gotta use that value somehow if you're giving it back. All right, if we're happy, I would like you to try. It's your turn. So you don't have to type this anywhere. You don't have to go to the written nice page or anything. But I'd like you to try this. Like open up idle. There's Python on the internet somewhere if you want to find it there, if you don't want to install idle again. But here's your job. I want to give you a few minutes to try this. And I can help you as you're working on it. I'll give you a few minutes. Though I want you to try to make a different version of this function. So here it is. There's like the first one. Instead of making that one again, which I've already made it, right? This one's giving back 1 plus 2 plus 3 plus 4 all the way up to n, summing up all the numbers from 1 to n. I'd like you to make a function called sum odd 1 to something. And what that one will do is it will sum up only the odd numbers from 1 up to n. Does that make sense? So your function that I want you to make, call it this, sum odd 1, 2, and then have it take a number still, but don't have it add up 1, 2, 3, 4, 5, 6, 7. Have it add up just 1 plus 3 plus 5 plus 7. Does that make sense? And this is apparently going to end up being 16 for this call. So does the question make sense? How I want you to change it? So add up only the odd numbers and call it something different. There shouldn't be too many things you have to change, but think hard about it. How will you change this function? Take what I gave you that sums all the numbers from 1 to n into one that only sums the odd numbers from 1 to n. All right, so give that a try. I'll give you a few minutes. We got plenty of time. And I can answer any questions that you have as well while you're working on it. So please try that. If you don't want to install idle, you can probably just search for like online Python. I assume that that's there. This one doesn't have turtles or anything like that. The first line has to change, right? Because that's we got to give it a new name for sure. Try to get that to work. You don't have to post your answer anyway, but help each other if you're sitting next to somebody. Try to convince your neighbor that your plan is correct. Hmm. Hmm. And then which line is going to make it skip over some numbers, right? That's what you want to look into. give you another minute head start, and then I'll show you my answer. Yeah, try to call your function in a bunch of different ways. Remember that you have to use the answer when you call it. You got to print it out or something eventually. It's always very loud. All right. Were there any questions that came up as we were trying this? Some of us get it to work. See the fruits of our labor. So, yeah, a couple things need to change. I don't think it's too much. There is one potential issue that we'll have to discover. What happens if you call it sum odd 1 to 8? What should happen here? I think it should be fine to just go to 7 still, right? Because 8's not an odd number. But maybe you want to have an if statement to yell at the user if they give you an even number as the parameter, because maybe that doesn't make sense. But we're just good to stop at 7 probably, and I think we don't have to change too much to keep it doing that. So yeah, I think there's only really 2 things that need to change. It's the name for sure, right? Some odd 1, 2, and call it that instead. And then the line that was dealing with going from 1 to 2, blah, 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 that was this one, right? We want to change it to go from 1 to 3 to 5, blah, blah, blah. Yeah. So this line needs to change. Instead of I going from 1 to 2, we want it to go from 1 to 3 and always be advanced by 2 each time. So if I just put a 2 there, it should work. Does that make sense? Is that what we got? So that should fix it. Or I guess there was nothing to fix. That should solve it. So here, let's try that together. I will call it sum odd 1, 2, and the only difference is right there. Boop, just like that. So yeah, I would like to do this. Call my little function. Be like, all right, print sum odd 1, 2, something, 7. We can multiply its answer by something because it's giving back the value, right? It's giving back a value, so it'll work out. Does that make sense? So that is the goal, and it should be happy. So what is, the sum was apparently 16, right? We're multiplying it by 2. So 16 times 2 is in fact 32. It looks like it's working, and it's happy. Are there any questions about why that's gonna work for that one? It's gonna only add up the odd numbers. Isn't that fun? We do have to decide what should happen if we give an even number as our argument. What should happen if I say sum odd 1 to 8, right? Maybe the right thing is just only just add up 1 plus 3 plus 5 plus 7. Just go up until the odd number before this one. I think that would work, right? And actually, our code right now will handle that just fine, because I will go from 1 to 3 to 5 to 7. 7 is still less than 8 if we call it with 8. And then we'll make it 9, but 9's bigger, so it will stop. It will only go up to 7 right now. If that's what you wanted, you're golden. You're already fine. You see that? That's quite nice. So yeah, maybe that means then that implies that if you call it like this, you get the same answer. Same exact answer as if you called it with 7, because it's going to stop at the same place. It's only going up to the odd number, right? That's either less than or equal to the one that you gave it. If this is not odd, it's going to stop at the one before. It's going to stop at 7. Does that make any sense? That's fun to think about. All right, yeah, and so that's functions in a nutshell. And I think that's the end of this example. Does it make? Are we happy enough to move on to one last topic? All right, so yeah, the whole point of functions is that we are going to call it a bunch of times. There's no use making just a function if you're going to call it only once. You just write the code then. But if you want to call this function a million different ways, like, all right, I want to sum up all the numbers from 1 to 7, 1 to 5, 1 to 3, like, then you get a payoff, right? Then you just have to call it a bunch of times rather than copying and pasting all this code a million times. Yeah, so that's the beauty of functions. It helps us reuse code, and functions are the main way to do that in programming. Okay, so for my last topic, I want to talk about kinds of variables. We have not run into this problem because we have not learned how to make functions yet, but functions give us a new place where variables live, kind of, and functions or variables that are defined inside of functions have a shorter lifespan, unfortunately. If you want to think about that, it's a little sad, but it works out in our favor as programmers. So there's some words I need to teach you now. So if you make a variable just outside of anything in the outermost code, like we've been doing all up until this lecture, just say like x equals 42, that variable is outside of any function, and it's called a global variable. I actually should probably make a file just for this topic. Let's do that. So I'm going to tell you the difference. There's global, and there's another thing. The new thing is called local. Local versus global. So that's what I want. And if you say this, you say x equals 42. This is a variable that like anybody has access to. You can access it inside of a function. You could access it down here later. You can use x in some way, right? Because it exists. Everybody gets to have it. It's global. It's a citizen of the world. So this is a global variable. Everybody gets to use it. It's globally accessible. It is visible to everybody. So everybody can ask for x and print it out for the rest of the program now after it starts existing. So like that. That's just normal variables that we've been using so far. It's a global variable, really. That's what it's called. And there it is. There I am using it. Anybody can use it, including people inside of functions. They can use it. If you make a variable inside of a function, though, it only lives for as long as the function is being called. That's the difference. It's a little weird. You have to get used to it. It's called a local variable. Like it's zoomed in. It's smaller. Only the function can use it. Only the people in the neighborhood, right? And your parameters technically are variables, and those count as local variables. So like when you call your function sum, right, with x and y, the x and y's, they go away after your sum function is finished. There are no x's or y's anymore, unless you had one as a global as well. Then it would have been a different x, though. All right. So yeah, you make something inside of a function. It's called a local variable, and your parameters count as those. And that's a bit of a different thing. So here, let's be like, let me make a function called blah. Just blah. It's going to take nothing. It's going to call it with nothing. I can ask for x, because x is global. X, anybody can use. So I can be like x times 2. I can use x here. X exists in here because it's global. It exists everywhere. Right? Everywhere. I can also make my own variables inside of this function's body. And be like, at y equals 3, make a y variable. And this y is a local variable. All right, that's different. Different to x now. X is out here, x is global. This y is part of the function's body. It is a local variable. It lives for the life of the function call. I can use it during the function, of course. Be like, y times 2, that's fine. But y ceases to exist after blah has finished. So down here, outside of anything, I can call blah, of course. But y is gone by the time blah is over. So do you kind of see what's going to happen when this code gets running? Be like, all right, x equals 42. There's print x. There's my 42. And then we call blah, so we jump and we run all these lines. So we print x times 2. X is still 42. X 84 down. Print that. Y, that's a variable. It holds 3. Print y times 2. There's 6. All right, so it's working. But what if I try to print y right here? This is the difference. Y is gone. Error. y is not defined anymore by the time you get there. So that may seem surprising, but now you know. All right, so y was a local variable, only lived for the life of the function called a blah. So after this line is over, that's the end of blah, right? Y goes away. There is no y outside. Does that make enough sense? And that's useful because now you can like reuse variable names. Like you can keep things nice and like safe just for you inside the function implementation. That's kind of why that works. So let's see. Yeah, that's that. And then one other thing you can do is you can't actually change the value of a global variable inside of a function unless you say something special. Because if I said this, like x equals x plus 1, now it kind of looks like I want to make a local variable. Does that make sense? It's kind of like it's clashing with this x equals 42, and so it won't do exactly what we want, and we'll get an error actually. So if we wanted this line to work and modify our global x, you can always look at the value of a global variable inside of a function, but if you want to change it, you have to like, usually that's something you don't want to do, and so Python's trying to protect us. If we want to tell Python, no, I know what I'm doing, I want to be able to change the global variable here, we say something up front. We say global x, just to mark it as like, I know that this is global, I'm going to mess with it now. That's all you say. If you want to set a global variable, you can always look at one. If you want to set it, though, inside of a function, you say global its name, just on a line by itself before you ask about it. So if you say this, global x, and then you're telling Python, trust me, I know what I'm doing right now. I'm going to mess with this global x variable. Use it inside of here, please. That's telling Python, I want to modify the global variable called x. And now this line will work. Now it'll make x 43, and now it'll print what? 86. And it's happy. But y, we can never get around the fact that y is gone by the time we get to here. Okay. So highly encourage you to like run this in like the Python tutor website. That would work. But I might as well just draw a picture for you of a stack diagram, because that website will also give you a stack diagram, won't it? So let's see here. What was happening when we get to, let me try and prove to you why, like y is gone. So let's get to here. Let me draw a picture of like what's going on when blah gets called. All right. Let me just, I don't know, maybe I'll just go through the whole program maybe. So we start our life with nothing to do, but then we start running the outermost code. So that's the stack of work we need to do, outermost code, run all those lines. Outermost code. And all of your global variables live in kind of in this box. All right, so we make an x variable, it holds 42 in the outermost code, so it's global, it lives kind of here. Let's say there's x, and we can print x. So there's my 42, that's why we're printing x first, 42. And then we define a function, but this code is useless until we call it, right? So we kind of skip over all this, and then we get to the call. So blah gets called, and so that's some work to be done. We add it to our stack of work. And then here's blah. Blah is being called. And we run all of its lines. So what does blah do? It's like, all right, I'm about to change x. So it's setting that back up. And it's like x equals x plus 1. It's talking about the global x. So that is it setting this to 43. So that's what that change did. And then it's printing x times 2. So really it's another call. Add it to the stack if you want. But it's just going to compute 43 times 2, right, to make 86 and print that. That's why we see 86. And then it makes a y variable. That's a local variable to the blah function, though. So it lives right here, y. And it held 3. All right, so it's a different place. It's a local variable. And we'll print y times 2, so we'll compute the 6, right, using y. Y still exists, so that's fine. And then print out the answer, 6. So I see that. And that was the last line of blah. So now blah, the call to blah, is finished. So it goes away. I really should be erasing it, but I'll just draw a line through it. And all the memory associated with the call as well goes away, including the y variable. And so that's why, by the time we get to here, printing y, there is no y. Y is dead, sadly. Dead and gone. So I think that is what I wanted to say about that. I hope that helps. Does that make enough sense? Questions about locals versus globals? I do think the Python tutor website would help with this. Let me show it to you. Always go there if you're concerned about something. Like Python tutor. Beep. Python. This one. I don't know if it's going to be happy because I have an error. I think it's fine. Maybe. Maybe. All right, so we're at the start. X equals 42. Woo. Global X. You see it? These words, they're used. Sorry, it's a little small. I don't know how much I can make it bigger and have it still be visible. So there's all that. I do have to zoom out so I can use this button. This is our output window, by the way, right there, right? And then we say print X. Boop. There's our 42 being printed because X holds that. And then we define our blah function, but we don't call it yet. So like it's going to jump over the definition. And now we're inside of the call to blah. We're about to call blah. All right, we're about to call blah. Boop. And so we're inside the blah function. See how it made another, it's kind of drawing it upside down. But like there's the outermost code. Here's the blah function call. This is a very helpful website if you're ever concerned about something. Now it's run all the things. The global X is just like a specifier, so it skips over that. X equals X plus 1 is going to modify the global X variable. Boop. Now it's 43. Print X times 2, computes it, prints 86. Y equals 3. See how that lives inside of blah rather than in the outermost code, the global variables, part of blah's stack of work to be done. Does that. Print 6. And it's like, all right, my return value is nothing. I'm going to return nothing back to whoever called me. It knows that. And then now we're back here about to print Y, but that is sadly an error. Y is not defined. And we can see that now because, like, if I rewind, right as it returns, all of this information about block goes away. The function call is complete. All the memory associated with it is gone, including all of its variables because they were just local variables. Okay? I think that is a good place to stop for the lecture. Are there any questions about any of that we talked about? Okay. All right, that was a fun example. And yeah, in the remaining time, I want to tell you about your next and probably your last extra credit opportunity. If you would like to do this one, this is a Python review extra credit opportunity. So I will 100% be asking you Python questions on the final exam. All right, I couldn't ask you Scratch because it's all like visual and clicky, but on the final, for sure, I could ask you to type text, right, and be Python programs. So in order to study for that, I will give you some extra credit, just forcing you to study, and you'll also help your peers this way. So if you would like, it's worth up to 5% extra credit, no late submissions, and you can make a review video. So make a little mini lecture maybe, where you go over some Python topics, like do some turtle stuff, go over things that we've talked about that will probably appear on the final, right? All the things that I've talked about in code, like have some example functions. Maybe your functions can do turtle stuff. I don't know. But like go over a few things, and you'll post it here. Like you'll click reply, and like all of your peers can see it, and so it'll help them review, and it's also going to force you to review for the final. So I think it's a win-win. And you can just post the video. You don't have to like edit it or make it pretty or anything. So you can either submit a public link to it or upload it down here. I think you can upload it straight to Canvas. You know how to record yourself by now, right? And yeah, here are your requirements. If you would like to do it, just make a video that kind of like is a mini lecture. It's like go over a bunch of examples, one or more examples of Python stuff that we've talked about. I'm excited to see how cool things that you create. Your rule, of course, is you can't just like copy something I did in lecture. You can improve on something I did in lecture as long as it's substantial. But if you just redo something I already did, that's useless, right? And so that's not extra. So yeah, do something extra for extra credit. Ask me if you have any questions about that. And yeah, just like go through stuff. Maybe pretend to be giving a little mini lecture. That would be helpful. Make some slides, maybe whatever you want, and go over some examples. Demonstrate, talk about like why it works, why there was an error, why you fixed the error, stuff like that. If you want just the half of the extra credit, make please a 15-minute video going over stuff. And if you want the full 5%, please make at least a 30-minute video going over a bunch of examples of stuff that you potentially will be tested on. All right? So yeah, just make sure that you have to make something new, right? Do something extra to receive extra credit. If you are at all concerned about whether your idea is novel enough, talk to me so that you get credit rather than not get credit, okay? Yeah, you know how to record yourself by now, but I can help if you're having any trouble with that. I think that's all that I wanted to say. Are there any questions about the extra credit assignment? There is a due date somewhere. I don't know if it's easy for me to see. It's due this day, May 9th, which I think that's like a month from now. I assume that's like the Friday before finals week, as late as it could be probably. But that is your extra credit. We're good with that. If you want to do it, you can do it. And I think that's all that I wanted to say. So I am done talking now.